And that's all for today. Thank you very much. Can we start now? Well, welcome and thank you for coming to yet another Kubernetes Meetup. Today we have 4 awesome speakers. Not 1, not 2, not 3, 4. So, quick word to the speakers. We don't have much time. Please do not overrun. Thank you. As usual, we will end up in the pub. It's the Tavern Singer. I think I put a map, but I forgot to put the slide, I think. But we will see that. Who is a first timer in the meetup? Wow. Well, welcome, everybody. Thank you for coming. Let's talk sponsors. First sponsor, Monzo. Thank you for hosting us, for the pizzas, for the beer, for the video. What is the video? That. My mom really likes to see me talking, making jokes. You want to talk now or you want me to talk later? Yeah? Yeah?
Thanks, Ivan. Hello, everyone. My name is Marcelo. I work in the hiring team here at Monzo. Just wanted to, well, first of all, thank Ivan for organizing once again together a meetup, the Kubernetes Meetup here. Just wanted to welcome you all to Monzo. I hope you have a great event. Just wanted to let you know that we are hiring for different platform roles, backend engineers. We have a few of our engineers here, so we can identify them by wearing like Monzo jackets or jumper or t-shirts. So some of them are there. So feel free to grab them if you want to talk and have a better understanding. Yeah, they're raising their hands there. Yeah, I just hope you have a great event, and thanks a lot for coming, and I hope you enjoy. Thank you.
So they are hiring. I applied for aerobics instructor, and they didn't accept my. They said that I was too good. Yeah. So if anyone is hiring an aerobics instructor, you know, let's talk. Yeah? Okay. Second sponsor, we have a fantastic sponsor for the rest of the year. It's OpenShift. A big round of applause for OpenShift, please. Thank you. And is Dominic around here? No. Well, she and Margot have created something called Meetup Mates. Go to meetupmates.com. There's a video there, very funny. And yeah, it's basically about helping people to get into the conference and community, because it's very different if you have a mate that introduces you to people that if you don't. And as usually, I will tell everybody, please be kind to each other. Thank you for coming. Carmen is getting nervous and stressed because the slides are not changing.
That's okay.
It's all right.
There we go. Good evening. So, before I get started, I love to get a sense of my audience so that I kind of can adjust my talk in C2. So I want hands to go up, and I want them to go up enthusiastically, or I will nag until they do. In addition to it being your first meetup, how many of you are in a professional setting using Kubernetes or operating Kubernetes? Raise your hand. A lot. Running Kubernetes in production? Raise your hand. Good. Using Kubernetes with a cloud provider, a managed provider, AWS, GCE, Azure, okay. Running Kubernetes, rolling out your own. Who's rolling out their own? Okay. How many people run Kubernetes on Mac? Wow. And Mac at scale or in Mac clouds? Yes? When I say Kubernetes on Mac, am I imagining that it's just your personal MacBook or maybe a thing that you SSH into, a MacBook that's elsewhere, maybe. Who use Mac's servers, whether that's a Mac Pro or an Xserve? No. So this is what that talk's going to be. I'm in a very special place. Last but not least, your hand raising isn't done. Use the other hand if you're already tired. How many of you consider yourselves old school systems administrators, sysadmins? Come on. Ooh, cool. So how many of you still think that you're doing that, but just now with a new neat title, calling like DevOps or Kubernetes? All right, I'm giving opinions now, but thank you for raising your hands because I'm of the same opinion. All right, let's get started. I'm Carmen. When I agreed with Ivan and Milos to do this talk, I was an infrastructure engineer at Travis CI. Who uses Travis CI? It's a hosted platform. Okay, for CI/CD. Okay, great. It's like a Gmail browser-based thing for CI/CD if you use Jenkins. But I'm no longer that. As of about a month ago, I joined the Go team at Google. How many of you program in Go or thinking about programming in Go? Come talk to me, because that's my new role. So having said all of that, because this is no longer my job, and because I'm on holiday and I'm here with my mom, back there, hi mom, I didn't prepare slides for this talk. That other slide was the only slide. So I wanted to use a meme and say, I find your lack of slides disturbing, but I really want to go on holiday. And so this is me just talking to you about Kate's on Mac with just browser tabs and GitHub repos. Cool? Are we cool with that? Okay. So what do I want to talk about when I talk about Kubernetes on Mac hardware? Okay, so you know about Mac hardware probably because you own a Mac laptop or maybe a desktop, some sort of Apple, but none of you have used a Mac server. And so there's some problems there when running Kubernetes on Mac. And the first is that it is Linux, native Linux, right? And the second is that there is no such thing as a Mac cloud. There might be in 5 years, but there's not right now. And so when I say Mac cloud, there is such a thing as a Mac data center. And I want to take it back a little bit and say, what is the difference between a cloud provider and a data center? Can anyone shout out what the cloud does that a data center doesn't? Anybody? Yes. Special logic. Yep. And what does that special logic include? Virtualization. That's a big one I'm going to talk about. We're also talking about networking. We're talking about like, even if you're just, who racked and stacked their own blades and switches? Ooh, you are legends. But we don't do that anymore with cloud, right? And nor do we sort of kind of give declarative configuration to figure out networks and subnetworks and regions and failures like that, but we don't actually wire that in the way that old school systems administrators did, whether they had their on-prem solution or whether they're using a data center. The Mac world, I have some problems. My first problem, I can't really give you some of the details because of Apple's licensing, right? They have a EULA, and so I can't give you specific details, and I don't know how much of the details I'm going to give you if they're going to call me up and be like, hello, because we've done some things, and we always are running into this user license agreement when running these builds. So, all right, I gave you all this backstory. The last thing I want to say about virtualization, Kubernetes. Virtualization, you're using AWS, you're using GCE, you take for granted KVM, or what is KVM's, the other one that GCP uses, the other hypervisor? Zen, right. And so we have, to be able to run anything on cloud, you have to have that as a basic fundamental building block. And we have just all but forgotten it because that abstraction is so tight and so secure. That is what gets you to run a container runtime, make like Docker, and that is what gets you to run Kubernetes. And when you don't have that in Mac, what do you have? Does anyone know for your hypervisor to run Mac servers? Take a guess. VMware. Who's used VMware? Who's used vSphere? Good. All right. So we're kind of getting there, but there's some kludgy things there with VMware. So I talked about that. Where do I want to go next? Okay. Travis CI. If you are an Xcode developer, an Apple developer, iOS, TV, whatever, we are running about on the order of 33,000 builds a day, which is pretty small scale. And people ask, well, why do you need Kubernetes for something that's that pretty small scale? And when I say jobs or a day, that is instantiating a virtual machine that has a bunch of Xcode on it or whatever golden mastered image on it. That person runs their Xcode or their Mac stuff. It boots, it runs, the build passes or fails, it sends the status of build pass or fail to the user, it shuts down and repeat and repeat and repeat 33,000 times a day, times, whatever. And that's all on Mac hardware. And we cannot use Kubernetes on Linux hardware and some maybe virtualize in because of user license agreements. So we had to figure out a way to run a Kubernetes cluster on Mac. And so now I'm going to get to the point of my talk where it's like, okay, really what we're doing is we're like nested virtualization. We're really running Kubernetes and our API cluster in Linux, virtualized on VMware, but on Mac hardware. So that's the first thing, but I hope that that's not too disappointing and it's let down because it gets a little bit more interesting in how we did it. So I say 33,000. How many of you are used now with containers and orchestration? I think elasticity of capacity is kind of just a moot point, but who still uses maybe EC2 or Elastic Compute prior to moving to Kubernetes and understands that? In a Mac data center, your capacity is fixed. So you can't just say, okay, scale that up, right? And that is kind of at odds with the philosophy of both containerization and with Kubernetes. And so we had to get very, very smart about understanding how to make the best use of our fixed capacity. We also have some additional restrictions in our EULA. We can only run so many copies of Apple hardware at any given time per the hardware unit, whether that's a server. And so we have all these like interesting constraints that we have to get out. And so that is why, even though it's not at scale, Kubernetes had some interesting solutions for us. So the first thing I wanted to show was I have about 11 minutes. I want to take 2 or 3 minutes to say what we had and then what we moved to. So right now, who uses maybe a blend of Terraform or uses Terraform as part of their Kubernetes setup? Right. So those that don't, the reason why we do is because it's a chicken-egg problem. Terraform, a HashiCorp tool, is a provisioner, an infrastructure provisioner. And before you can use your K8s API cluster or bring that up, you have to provision it onto the cloud of your choice. And so that is why we did it. Before we moved to Kubernetes, we used Terraform with just horrible bash scripts, a big, huge bash script called bootstrap.sh. And there's an interesting additional layered problem with the Terraform provider and vSphere. Because the Terraform provider and vSphere doesn't really work well with Mac hardware, which has its own nested API calls. So there's, it's a lot. I think it's 4 layers of API calls that have to talk to each other, that we have to wire together. And we wired it together with 2 services written in Go at Travis CI. The first is a worker pattern, which is a pull-based worker that does all the automation for these VMs. And the second is a wrapper on top of that called Jupyter Brain. Everything is open sourced in Travis CI's repo. And that is the wrapper that has our automation talk to the vSphere API and be Mac ambient aware. It's very interesting. And I haven't even gotten to the Kubernetes part, but that's what we had before. I haven't even talked about how we got into sort of storage, SANs, like the storage, to be able to sort of pull, because I don't have enough time. I have 10 minutes. So let's get finally to what we changed for Kubernetes. So what's relevant here? Once we went from Terraform to be able to sort of try to provision all of our worker cluster and all the internal automation, but using a bash script to do it via Terraform plan and Terraform apply, we decided that we wanted to have Terraform only provision the Kubernetes API cluster, and then once the Kubernetes cluster was brought up and running, then the Kubernetes cluster would take care of all that provisioning. And so that was the first change that we did. And if you want to look here, we did that under Kubernetes config. And MJM is Matt Moriarty, who really is my former teammate at Travis and gets pretty much the lion's share of the credit and has led this, came from Apple in their Xcode build system. And we just had a lot of talks about, because he came on and saying, I don't understand what this systems administration kind of thing is, and was interested in learning. And so it was kind of a blend of people who, a network engineer, myself with Go, and then Matt with the Xcode, that was the perfect union of this collaboration to be able to bring this together. In Kubernetes config, what's interesting about there, let's see here. We have some challenges in the fact that, again, I mentioned that the Mac isn't really a cloud, it's a data center, and we have a limited amount of hardware. The compute is the biggest bottleneck, and again, because of EULA, but also because it's not elastic. But we have this cutoff of 2 or 3 hours, depending if you're a paid service of Travis customer or not. And we kept, for rolling updates of our services, they were horrible, because we had automation that would send a signal, right? And this could be a process, this could be kills to the VMs, if not. And at first, the Kubernetes, okay, we all know how Kubernetes doesn't really model statefulness well in services, right? And so how do we keep the total numbers of Travis jobs running when we're trying to drain the pools of the existing while updating the new versions of Go? And so the thing that we chose to use was CoreOS's, let me find it here, the worker operator pattern, or the operator pattern. So how many of you have used CoreOS's operator pattern for stateful services? So it is an interesting thing because it is a community that's trying to grow. If you've used their Red Hat and CoreOS are the same thing, but it's kind of like trying to use like Ansible, but for the Kubernetes world is how I would think about it. How many of you use Ansible? I'm just kind of doing the whole thing. So this operator pattern has lots of libraries in there. I would suggest for you to kind of just take a look because they're building on it. And it uses many different libraries for some sort of stateful services. And our stateful service was, we have a draining pool that we have declared in our infrastructure automation. We say this was maybe the worker version 5.4.0. We were putting a patch up, 5.4.1. We cannot scale capacity, if you remember. So we can only put down some and others. And Kubernetes, the pods, had their own replica sets. And they were kind of clashing with the declaration of the pool sizes within our automation. And so we were having to do things manually, and it just defeated the purpose of having Kubernetes. So this worker operator pattern really was the sweet spot that we found, right? So it would watch the terminating pools drain, and then it would add capacity along the way so that we wouldn't go. And so it kind of kept things running about at the capacity that we needed to, and so it was kind of our service communicator, right? And we don't use Istio or Envoy if you're probably running at scale, just because we found that the Kubernetes was enough for us at least at the scale, and the worker operator pattern got us the rest of the way. So it just, once we were able to do that, we were able to sort of have better rolling updates, and we would just kind of use GitOps, right? So it would just be a git push to master, and that would solve all our problems. And I mean, I kind of gave you about an 8-month transformation story in about 15 minutes of time. But once we had the worker operator pattern, really it was just a simple git push to master. Some other things that I wanted to say about worker operator. Yeah, we use the K8s API to get the worker processors running. And if I know I should have done slides, but I'm on holiday. So there's worker processors, they have pools, there's replica sets in the K8s API. And so we only wanted to have one single responsibility per each, and now they don't do that anymore. And the side benefit of the worker operator is that, and I would say that for most people that are looking for an operator pattern, is that you can be more declarative this way, right? Because you have the replica sets and you have some of the K8s world kind of interfering with maybe some of the legacy stuff or things that you're running in for some of the statefulness that you've set in your whatever paradigm that you've had in your automation. Let's see what else here. Yeah, so you don't have to, you can kind of just be like, I really just need to care about this many processes, and you're not doing like replica math. How many of you have tried to already do like figure out replica math and then put that into your like, you know, YAMLs? I don't know, yeah? Okay. let's see what else here. Some caveats. I haven't mentioned this in the system design. This all works because we don't use HTTP APIs. If we did, we'd probably move to Istio. Right now, our pull-based worker, it goes over RabbitMQ or AMQP. People familiar with that? Yeah. So that was the first thing I wanted to say, and Istio is too big for our scale. And then I feel like that's kind of the story. We had some clumsy bash going on in Terraform. We had to manually rotate through all of our services to restart them or update them or patch them. It was horrible. And we turned it into a Kubernetes worker operator and Kubernetes configuration. That's the basic infra for our cluster. We run it all virtualized in VMware via their hypervisor in Linux, but on Mac hardware. I guess a couple other things on top is that we have Helm charts. We just use Helm charts for the Kubernetes config. And the other thing that I wanted to say is for our master imaging, and this may not be a use case that many of you hit, but we had many customers that say, well, I want to use an old version of Xcode because it targets like ancient Mac OS or OS X's, right? Because they're kind of trying to get as many test cases as possible for people not upgrading their machines and or their Xcodes or their smart OSs or watch OSs or ISs, whatever Mac devices have you. And as a result, we decided to also automate our image mastering, and we use that for Kubernetes as well. That is such a niche subject that I didn't think it would be worth kind of banging on about, but it certainly is interesting. We use Packer, which is the other thing that you use for such things with the HashiCorp tool. And then we have Kubernetes that kind of just pushes that out. All right, so I have like 2 minutes. It was, I know, this is kind of an interesting engineering problem, and I really enjoyed doing it. I do call it infra on hard mode. I don't think many people have this unless they are in the business of doing some sort of infra for the Apple ecosystem, and Apple should do more of what Linux does, but they don't, and that's in a whole nother story. So I have 1 more minute. Any questions? Did I blow your minds or like make you kind of tune out or whatever? All right. Thank you, everyone, and hope you enjoyed this weird, wonderful ride.
Thank you, Carmen. While Kir is coming here, I will ask, who is interested in learning about operators? Who is trying to build an operator now? Come on, don't be shy. You? Okay, it's like we've been talking about doing a deep dive on security and operators, and I'm just trying to figure out how many people is interested in a session like this. So I'll repeat the question. Who will be interested in a deep dive with operators and controllers? Okay, awesome. Thank you. And welcome, Kay.
How do I switch slides?
Put it in your pocket.
How do I switch slides? Oh, cool.
With the clicker. Oh, thank you.
Hi. My name is Kir, and today I want to talk about autoscaling on Kubernetes on an example of one of the world's largest e-commerce platforms, and share some lessons that we learned while working on that. I work at Shopify, which is a commerce platform for all sorts of businesses, from entrepreneurs to large companies who want to set up an online store and sell their products. They come to us, create the store on our platform, and advertise it, and we get all that traffic from people who want to buy some fancy sneakers from those merchants. And my team at Shopify is responsible for scalability and reliability of the platform. And we're also responsible for things like making sure that we are ready to accept any amounts of traffic, even for events like Black Friday. And that includes stuff like capacity and and scaling Kubernetes clusters. Like many of you, a couple years ago, we made a call to move from data center to Kubernetes in cloud. Just like Carmen was saying, one of the key differences between data center and the cloud is the elastic compute, elastic capacity that you can ask on demand and use anytime you want. And when moving from data center to cloud, we've had so many things to take care of that we still used some of the previous data center assumptions. Like we always have a limited number of virtual machines, fixed number of application servers that we increase maybe once a quarter based on our calculations, and always keep some extra buffer to make sure that we can accept the load. But now, when we were in cloud, why not autoscale? We've had a couple big reasons for that. One is elastic capacity planning. Instead of having that process of planning, okay, how much hardware, how many nodes we need for the next year or so, we could rely on some autoscalers that would do the work, most of the work for us. So we could reduce some toil. And at the same time, we could save some resources that were not actually needed, because we often had to run over-provisioned, because in data center we could it was so much work to set up all the hardware and to order it that we couldn't scale as easy as in cloud. And when talking about autoscaling, the way I see it is that there is short-term autoscaling. For a commerce platform, you would get these waves during the daytime and the nighttime, mostly in North America. That's where a lot of our customers come from. So you could obviously shut down some unneeded compute during the night. Of course, I'm talking about stateless work. And at the same time, there is long-term autoscaling, which lets you plan the budgets and see how the platform grows over the years. And we were still using that static capacity mindset. As we started looking more and more into autoscaling, we realized how much more unpredictable this environment is. For instance, if we wanted to scale in on demand, we would need to assume that it takes some time to bring up the nodes from GCP or whatever cloud platform, cloud provider we use. Then for those nodes to become ready as a Kubernetes node, pull containers, start the app, and overall that time could be 5 or 10 minutes, depending on how heavy the app is, how heavy the containers are, which for us meant that we cannot be reactive when autoscaling. We have to be proactive. We have to autoscale in advance based on some patterns that we could see. So that because if we're only reactive, it would take us 10 minutes to autoscale when we are already in the state of not having enough capacity, and clients of our merchants are not able to complete checkout in the online store. There came more concerns about scaling on demand. As we learned, cloud does not mean unlimited computers. We could easily hit limitations of cloud platforms for not having enough VMs of certain sizes that we preferred in certain availability zones. Then we thought, what if we scale down, but the provider does not have nodes available to scale up because every client of that provider wanted to move to US Central if there's been some issues in US East. What if everyone performs a failover as well as us, and there is no enough virtual machines? As I said, we've had to think about all the things that came for the autoscaling and understand why we're doing this and that it's worth it, taking into account things like unpredictable notion of traffic, how much time it takes to scale up, and the fact that we need to be proactive rather than reactive. After talking about some of the concepts, let's move on to how this maps to the Kubernetes world. So we have pods, which are containers, which are actually the units of work that we have running, and we have nodes. Pods are usually a subset of a deployment, and deployment would have a number of replicas that you scale up or down. During the busy time, you would have 600 replicas, and during the low time, you would have maybe 400. Totally depends on your workload. So TLDR of autoscaling in that way was to increase or decrease replicas based on the demand. Just needed to figure out the algorithm, how you want to scale it up. Fortunately, there comes a built-in Kubernetes primitive called horizontal pod autoscaler, which is usually abbreviated into HPA. Which is a Kubernetes component that accepts rules like target CPU utilization at some percentage, and it does all the work in adjusting replicas for you. So we have pods managed by horizontal pod autoscaler, which increases or decreases replicas. And then we have nodes. For us, we've realized that the logic for adjusting replicas, it was a lot more complex than what HPA does. We wanted to support a lot of business logic, things like planned sales, overrides, to be able to kill switch autoscaling with a single Slack command if we're uncertain, and fall back to max manual capacity. We also wanted to take into account multiple metrics, multiple providers, and be as resilient as possible. If the metric provider is down, we always want to scale up no matter what, just in case that our customers are not suffering. At the end, we could build and compare, based on historical data, multiple algorithms that calculated number of replicas that we needed based on the metrics. So in our case, we've replaced horizontal pod autoscaler with some Go app that takes all the environment as an input and scales replicas up and down. But we have to think about what happens on the a bit on the bottom of the stack, because pods in Kubernetes is just an abstraction. What actually happens is that Kubernetes schedules those pods on nodes, and if you want to have thousands of replicas of those pods and you don't have enough nodes, well, they will just not run there because you need to add more nodes. There we come to the concept of right-sizing the cluster. These boxes are pods, and right now our cluster, all the pods fit perfectly into the cluster. It's right-sized, meaning that there is no unused resources, and pods fit perfectly. At some point, we want to have more pods. We ask for more replicas, but Kubernetes cluster would not have any nodes to schedule those. So something needs to add more compute there so that those pods become schedulable. And the other way around, when we downscale, we get some unused resources, which we want to turn off. But that actually was a very ideal state, which almost never happens in real life. In real life, you would have Kubernetes would try to distribute pods around nodes evenly, but that would not always be the case. So you have some nodes that are running that are not utilized very well with a few pods, and some would be more utilized. So what you need to do first is to pack all those pods on nodes that are staying, and then those nodes that are not utilized, you'll turn them off and save money and be happy with your cloud bills. What I just described is actually another component of Kubernetes called cluster autoscaler. You can clone it and check it out. So we come to the end picture of cluster autoscaler managing nodes, right-sizing the cluster, and horizontal pod autoscaler right-sizing the number of pods and replicas. How much time do I have? Cool. Please raise your hand if you ever experimented with a cluster autoscaler. And cool. How many of you run on Gkey? You've probably run into this, but the thing is that on Gkey, all you can control is minimum and maximum number of nodes, which is unfortunate because you would want to tweak because actually if you go to GitHub and check all the flags and options that cluster autoscaler has, they will be super interesting. You can control how aggressive it would be, and how many nodes you want to bring up at the same time. And it's actually very interesting to read. But again, on Gkey, since Google runs cluster autoscaler for you, you cannot control much. We've run into this, as some people from other companies that I know have run into that too. And we've had to disable Gkey's cluster autoscaler and just run our own as a regular deployment in kube system namespace. Some takeaways from the whole autoscaling project that we've wrapped up recently is that before doing that, you would want to understand all trade-offs that will be there, that come to the cost of saving money on resources, cloud bills. It's also good to understand all abstractions, what actually happens when you decrease replicas, how cluster autoscaler brings more hardware, and what happens when that hardware is not available in the cloud provider. HPA, horizontal pod autoscaler, may be okay, maybe because it's quite simple, especially for if you have a very simple rule like target CPU utilization at some percentage. For us, we are a Rails monolith. We're not CPU bound. We have a lot more rules, we want to have a lot more logic around safety, about autoscaling. We have all those overrides and switch back to manual control from Slack with chatbots. So we had to implement our own thing instead of horizontal pod autoscaler. Reach out to me on Twitter if you're interested to chat about this topic. And thanks for coming.
Let's do a quick break and then come back in like 10 minutes, and then we carry on.
1, 2. Yeah. Thank you.
Can people please sit down and do you want me to make any jokes or just like you're
That's fine. That's fine. Yeah.
no jokes?
All right. Hello there. Good evening. Welcome. Thank you very much for being here. Ivan, Milos, thank you very much for inviting me again. My name is Paris. You can totally skip my surname. It's too long and complicated. I was here a year ago presenting for Ticketmaster our Kubernetes journey, which actually now spawns almost 3 years in production with a lot of good and bad moments and a lot of experiences. I know that some of you are customers and you have reservations. I totally understand. It's okay. You can hit on me afterwards. This presentation actually wouldn't be possible if I didn't have the help of one of my very shy colleagues that he couldn't make it today, but I have to give him credits. This is how he turns when I actually make, I name a variable in Terraform in a way that he cannot stand. He turns like this. So what we do, I represent a team actually that, let me use an analogy of a movie, let's say Armageddon or something like that. So I represent a team that actually is lift and shifting a 2 decades old platform into the cloud. And this is like the Ticketmaster website. Beneath the website, there's like 2 decades of legacy functionality. So it's not like rebuilding a shiny new fast website. It's actually vertically breaking things and re-implementing them or shifting them or whatever that means. So imagine that you are Bruce Willis on top of the asteroid and you are drilling and every day you're finding something new and then your drill eventually goes out and you have to pick another tool. This is how it feels sometimes. The project is almost like 50–60% done. I mean, the face is all new, but behind the scenes, this is where the real work. We've been using Kubernetes for the past 2.5 years, and we continue to use it as our main deployment platform. It's a very small team, and it's a team of developers. And I'm a developer as well. And I'm really sorry because the first part of my presentation is going to be a bit provocative for actually, hardcore sysadmins. I totally love you. Please don't kill me, all right? And actually, I want to start the first part of the presentation with the last point. We are actually experimenting. We are trying to be a vertical team. And I know this is like a buzzword for many of you that you might be managers or directors or whatever it is. But for us, it's like a way of achieving our goal. And our goal is a difficult one. So raise your hand if you are working in an organization that actually does DevOps like this. And I'm saying like the platform team and the developers. Come on, don't be shy. I know you're doing it. No? All right. Raise your hands if you're trying to do DevOps like this. No platform team, sysadmin skills or ops skills embedded into delivery teams. So it's a cultural battle, all right? It's a difficult thing. Usually we tend to work on that kind of structures because they are easier to manage and they're easier, to scale, and eventually they cost less sometimes, all right? But imagine that eventually if you pick your best projects out of your organization and you want to move fast, you want it like the best tools, you are Bruce Willis, you are on top of the asteroid, all right? You want an expert, let's say a geology expert. You won't keep him on Earth, you will take him with him. It's not like, hey, can you do this for me? Yeah, I have some other task now. I'll talk to you later. No, man, it's like we're going to die now. It's like, I need your help. So what this has to do with Kubernetes? So as developers, especially working in this project, we are experiencing some kind of technology and cultural change. I don't know, maybe it's happening to us. I don't know. Maybe you can you can think your project and you can tell me if you're experiencing the same transformation. So Kubernetes eventually came out of Google. Actually, it made Docker very, very, very useful. I don't know if you agree. And then started becoming a very successful orchestrator, and then started becoming the lingua franca of actually orchestrators. And now everyone is doing Kubernetes one way or the other. And development teams within organizations started actually having access to what the developers or coders call infrastructure. It's actually, it made infrastructure more approachable to developers. And this is like a cultural fit, a cultural change. Developers actually started going to areas where it's actually like a forbidden fruit for them years ago. So now we see that development skills and ops skills, in order to achieve, let's say, in order to achieve delivery, they need to coexist in a symbiotic relationship. And this is the message I want to pass the first, let's say, part of this presentation. And if you don't believe me, actually, this slide is, I'm not trying to teach you or show you all the logos of the main cloud providers. This cultural change about this merge of skills and, the importance of this symbiotic relationship and this vertical, let's say, way of seeing things is actually imposed by your favorite cloud provider. And those of you, what is common with all the, let's say, frameworks under the signs of the major providers? It's actually, may I say, developer-oriented tools. It's most probable that in the next 5 or 2 years, actually, most of your platforms will be written in Lambda or like thousands Lambdas or containers or whatever it is. The essence of the old idea of the infrastructure is getting mixed along with your code. All right? The faster you change, the faster you adapt, the better it's going to be for everyone. Now, talking about change. Our website actually powers a lot of countries at the same time. The whole Europe, the United Kingdom, and actually we have Australia and New Zealand. So we are talking about more than 15 countries at the same time. We are an AWS shop, so I'm not going to talk to you about Google or whatever it is. We have always been an AWS shop, and we know, we work on AWS, and this is not going to change. And we've been running Kubernetes, as I said, for the past 3 years. We started with a tool called kubeAWS. I don't know if anyone remembers that. Then we started using kops, another tool to actually configure clusters on AWS. And now I'm here to present you that we are actually one step away of using the latest offering from AWS. This talk is not affiliated with AWS. It's just sharing experiences. Now, before I start actually telling you the details and our experiences, and some of you may have even better experiences or whatever, this is the slide that kind of describes our mentality, all right? We want Kubernetes to work for us. We don't want to work for Kubernetes. And unfortunately, I see a lot of people, and maybe sometimes a lot of companies lately, Kubernetes is a hype, is the thing. It's a blessing, of course. But I'm really sad that I see people, when I talk to people, that actually, they're getting very specific on actually using all the things Kubernetes, and they kind of forget why they use Kubernetes. So for us, it's a very simple thing. We have a very difficult task. We really love Kubernetes, but it is what it is. We want to make our life easier. We want Kubernetes to be a tool. We want Kubernetes to be a drill while we are on the asteroid, not the asteroid itself. So, the Kubernetes universe expands. The Kubernetes universe has, expands and, evolves in terms of like solutions. It's really up to you and what you want to do. If you want to deliver, if you want to spend time on one of these, how you are going to actually to cherry pick all these different features that, this universe provides to you. Now, EKS. So now that I've explained that we want Kubernetes to work for us, and we don't want to work for Kubernetes, all right? And I'm a bit oversimplifying this. This is how I felt when I actually got, we were in a presentation from Amazon, a private one, and they displayed DKS. All right, we've been suffering for 2 years, with all these bespoke tools, even with COPS, and then try them to squeeze them in our AWS VPCs and networking and make the clusters work. And I was hoping, yes, finally AWS made it. We are going to have the Google Container Engine equivalent in AWS. And then the guys came. I don't know, is anyone from AWS here? All right. So they came and they just puked some, millions lines of CloudFormation. And they said, okay, yeah, there it is. Oh, no, this is not what I want. So we said, okay, let's wait. I mean, this is not working for us. Yeah, okay, you're solving the master problem, so they're giving you the masters, but the workers is like, we've been passed through CloudFormation. It's okay, that's a thing of the past. Things change, though. And actually, even if you Google now, if you search, if you do things, you will see that a lot of people actually are using EKS. And the overall offering has matured enough. And the very first thing that we really like now, it's like you have a lot of different ways of actually spinning EKS. And I'm not talking about the masters, because this is like a 6-line Terraform thing. Just spin me an EKS cluster with the masters hidden behind AWS Cloud. It's actually the other part, the worker node. And actually now you can find a lot of really nice stuff, really nice modules that can provide you this in a matter of hours. And we really love Terraform. We wish AWS could actually embrace Terraform for all the things, and that was one of the reasons that we progressed. So AWS solved 100%, we hope, the masters problem. So the masters, they're somewhere, they provision them, they update them, it's their problem. And if there is a problem, we know, we go to P1, we go support, and then we hope that everything's gonna be fine. And for the worker nodes, they are very kind, all right, to provide an open source, let's say, AMI that actually you can use in order to spin your workers. And this is actually based on another HashiCorp tool, Packer. So actually they kind of give you like 50% of the solution. Here's the AMI. If you want to change it, if you want to harden it, if you want to reprovision it, it's totally up to you. And this is what we do. We take this AMI, we change the PID, we make it more secure, and then we use it. I don't know how many of you how many of you are using cloud, I mean, a cloud provider like AWS, and you still maintain a lot of on-prem dependencies, all right? At some point, especially, your networking team, it's going to have a nightmare. Like, somebody is actually doing this, is connecting these two worlds, all right? And networking-wise, this can be like a nightmare, very difficult sometimes. So, networking within our Kubernetes clusters, all right, it was always like a big question. What's going on? What's happening? EKS, with the default, let's say, AWS CNI plugin, where every pod gets a proper AWS IP from your VPC, in our eyes, and based on our experience in the past, it makes things and maintenance far easier and troubleshooting far easier, especially for our networking low-level team. We have been spending a lot of time sometimes, all right, yeah, my pod. I mean, I had network guys from the on-prem data center team saying, okay, what's the IP of your application? Yeah, my IP doesn't exist. It's like an IP on an overlay network. So we had this disconnect. We're trying to see where the packet was getting lost. It was getting lost on the direct connect, on the bridge, on the NAT gateway, when it was actually crossing the boundary of the on-prem infrastructure. This is far better. Cultural problem, all right? Have you provisioned Kubernetes clusters and then you had to send to your colleagues some bespoke certificates or kube configs in order to give them admin access or no access or not? This was a big problem for us. Huge fights. No, the cluster is mine. No. This is our cluster. Give me admin. No. You don't have admin. I will email you only this certificate. This is the end, all right? EKS actually binds very well with a tool called AWS IAM Authenticator. If you already maintain, let's say, a lot of roles, users, or SAML authentication in the AWS, this tool actually proxies the calls from your kubectl. It can actually verify your identity. And based on configuration, you can actually give transparently access to your clusters without actually creating a lot of noise. Money. So spot instances. Those of you that actually use AWS, you know it's a very, very, very good way to bring your bill down a lot, actually. So now that you have, let's say, a provisioning solution from AWS using specific AWS tools on the AWS layer, makes it far easier to create Kubernetes clusters that they will work with spot instances. Specifically, 3 months ago, AWS released a very smart auto-scaling group, which is called mixed mode. It actually resembles something they call fleet spot, and you can attach it to your cluster autoscaler, the one that we actually saw in the previous presentation, and actually can distribute requests for new nodes using spot. We use this by default, almost 90% spot on all our dev and snapshot and pre-prod clusters. So even if something happens, nobody will die, just like a testing cluster. And the amount of money that we are saving is like tremendous based on our reserved or on demand, let's say, instances we have in production. So, and what about spot in production? There are people out there that are doing spot in production with Kubernetes, but this is like, if we take into account the previous presentation, all right, where you have to tune the autoscaler, you have to pick the correct sizes for your nodes. Adding spot in the mix is another layer of complexity, because now you don't only need to tune your autoscaler to have more than 1 or 2 or 3 autoscaling groups. You need to make sure that actually your application pods are being distributed in a way that if you have failures, assuming that the red dots are like spot instances, you're still going to have an application there. And this is a challenge. And to be honest, we are still trying to figure out the best way. And this is actually the slide that I think really liked, the audience really liked a year ago. And I wish we had let's say, the traffic patterns of Shopify. I'm sorry. Sorry about that. I don't know if Spotify have these patterns, but sorry, I just ruined the first slide of the previous presentation. So my apologies. But for us, it's Black Friday almost every Friday. All right, because we go from 0 to hero for about 30 seconds, and as I said, our let's say scaling events and on sales, they're lasting more like your sex sessions or whatever it is, or maybe less than sex. All right, because this can last for 30 seconds or 1 minute or 2 minutes, and then they're gone. And then something happens on Twitter, and then you have it again. All right, and they're never gradual. They go like this. All right. We saw some very nice points on how the autoscalers work, where there is no autoscaler that works with this. Believe me, we are trying. We keep trying. And the only thing that actually works is like, having a meeting or actually pre-scaling with on-demand instances just, 20 minutes before what's going to happen. Some noteworthy findings just for you if you're going to download it afterwards. Along with our new EKS clusters, we decided to change some of the components that we use internally. So we have set up our new clusters, everything is fine. And one of them is actually that we really like. It's a new type of ingress controller, an API gateway called Ambassador. If you haven't checked this thing, it's free. I suggest you check it out. It's a Kubernetes native API gateway. So it actually receives all the requests and then actually understands all your internal services, and with a very simple mapping, it can actually act as a proxy for you. That way, we managed to reduce our ELB bill in like almost 80%. Because we used to be, naughty boys, okay? Every service has its own ELB. And then when we received the bill, we saw that ELBs are not everything. I don't know how many of you have spent nights trying to understand why Fluentd is actually not pushing your Docker container logs into Elasticsearch because of this overcomplicated and complex Fluentd configuration file. So with our new clusters, we decided to give it a go to Fluentd Bit. It's actually the successor of Fluentd. It's written in C++. It has far simpler configuration, and actually, I think it's far better. So we are using Fluentd Bit as a daemon set in all our workers. It's pulling the logs from the containers and then shipping them directly to an Elasticsearch outside of the cluster. Now, do I have time? Only 2 minutes. Yeah? 2 minutes, yeah, thanks. So I really think that we should share fail stories as well, all right? Because nobody's perfect, all right? We should encourage that. So I'll tell you for the end a story of epic fail. So it's 9 a.m. It's a day that we know that we're going to go from zero to hero. It's a boy band on sale, all right? And boy bands are evil, I'm telling you. Especially young teenagers that they want their ticket, and that's the thing. And we are upscaled, but suddenly we've made a miscalculation. We didn't expect. This boy band is actually, I don't know, something happened the day before, and one member of the boy band said something, and now everyone is getting crazy. And the traffic is like that. I mean, the young teenagers are like the Urukhai. It's like they're attacking. You can see them. You can see them on the CDN or your ELBs. So the ELBs are getting warm. Our CDN is getting warm. Of course, we are offloading a lot of requests on this layer. But it's like we are overrun. I mean, they're going to win. That's fine. That's fine. The previous presentation again. Auto-scaling, horizontal auto-scaling, everything is starting to picking up. The pods are actually reporting thresholds increased. The horizontal auto-scalers, are getting ready, and they start issuing requests. Give me more workers. Give me more nodes. Fair, and that works. That works. If you set your limits, your auto-scaling limits a bit low, then actually your cluster, while it's picking the heat, is actually auto-scaling a bit, let's say, earlier than the moment that, Urukhai, they're going to hit you like on your ELBs. So this is expected. Then suddenly something happened. It's funny, but it's like, it's not funny when you see your clusters going like melting down and everything is like crash loop back off. So what's happening is like, we were asking for new workers, all right? These new workers were requested because Kubernetes needed more compute. Fine. It needed more compute to place more pods because the deployments needed more instances. Fine. All right? We had a single dependency, a company-wide ECR, a Docker registry, in a way. For some reason, our colleagues in the US the previous day, I don't know what they were doing, they have exceeded the API limit of actually pulling images from this ECR. So when our 2 clusters or 3 clusters tried to auto-scale, they actually issued a couple of API requests, and they all got denied. And then this happened. Kubernetes then actually went in a very weird state. He couldn't satisfy his horizontal pod auto-scaling events, all right? Then he started trying to fight the system, trying to attack, to fight its own self in a way. Killing the pods, restarting the pods, trying actually to shuffle the pods in order maybe he could actually place them in a worker that is kind of, all right? Nothing was happening. So that was a big outage. The lesson learned is like, sometimes if you rely on centralized dependencies, even though it has nothing to do with Kubernetes, all right, you can actually bend the system. So try, especially for your most critical parts of your infrastructure, to actually reduce the scope of your dependencies. A subliminal message for the end, just going back again on the start of my presentation, empower your developers. Don't isolate your development teams out of your infrastructure. Kubernetes is a very nice way to bring your development teams closer to the infrastructure. You're going to see gains. And this is how developers feel when they actually give them the keys for a new EKS cluster. This is what happens. Thank you very much for your time.
Thank you for your talk. And now, while the next speaker is getting ready, if any of you want to give a talk in this wonderful meetup, talk to Milos there. Milos, say hello. Or talk to me, or ping him in Twitter, or risk sending me an email. Jenkins. Where I've seen this before.
Yeah.
Well, thank you, Sam.
Oh, I'm not sure. Lost my speaker notes. There we go. Hey. Okay, so hello everyone. I'm Sam, and I'm going to be talking about diffusing Jenkins using GitOps. So this is a very GitOpsy talk. I think it was mentioned a little earlier on, GitOps as a concept. So, yep, I'm an infrastructure engineer at ControlPlane. We've done a lot of Kubernetes work. Oh, my face is really big. Well, it's not expected to be that big. Yeah, so we've done a lot of work in sort of secure, high compliance environments, very security focused as, yeah, it's kind of DevSecOps. ControlPlane is a little sort of, as I said, DevSecOps, security focused, Kubernetes and container consultancy, London-based. We do a lot of training and consulting. You know, this slide was put in by my boss, so that's why I'm going through quite quickly. Here we go. Let's get started. So, going to start talking about Jenkins as a target, a little bit on that, and then it's more of a user story of how we implemented a GitOps pipeline at a client to try and mitigate some of the some of our threat modeling around Jenkins. And then talk about our pipeline a little bit, how it looks once we've finished the pipeline, and then future improvements for our work. So Jenkins, yay. I'm sure everyone's familiar. Who actually uses Jenkins in their day-to-day? Yeah. It's very popular, which is also why it's a bit of a target when it comes to CVEs. You probably have all seen the little red tab of shame up in the top corner, telling you all of your plugins are out of date. That one's got a remote code execution on it. That one breaks all your RBAC, that kind of thing. So Jenkins as a target, it's a bit of a gold mine for any potential attacker in your infrastructure. It's got build secrets, so things get into your registry. It's got push access to your registries. So that means Docker secrets of some kind, usually. Also probably has Docker socket access, your slaves, since they are building Docker images. And as we all know, Docker socket access is basically root on whichever host you're running on. Some have creds to build infrastructure, because you're mixing your infrastructure provisioning with your building. And then, of course, some people multi-tenant their Jenkinses, which means that you've got one project accidentally lets someone who shouldn't be on into their Jenkins, and they've got other access to other projects and their secrets. And finally, a lot of Jenkinses will do CI work and production work, and that's really what I'm focusing on, is reducing this final one of, you've got into Jenkins, how do you get into prod? This could be deploying a Bitcoin miner to prod. It could simply be deploying a poisoned image with a supply chain attack. Or it could simply be hitting an outdated Kubernetes cluster and manipulating a CVE on Kubernetes itself, because these Jenkins will usually have some kind of direct network access to your infrastructure, at the very least. So we started to mitigate this with a GitOps workflow. Who's familiar with GitOps? Or yeah, that's good, more than I was expecting. So we've got a nice little diagram here. So this is basically the idea behind GitOps, is that we start using Git-based operations. So this means that every change to our infrastructure, to our Kubernetes deployments is reflected in Git, and then Git becomes our source of truth for what is in Kubernetes. And the core concept behind GitOps is we're changing from a push model of deployment, where we sit somewhere and we tell Kubernetes this is how you should be, to a pull model, where Kubernetes is watching someone and saying, okay, this is what I should look like. And finally, this means that all changes that we have to our cluster are observable in Git. And then that makes it quite easy to roll back. Talk about a little later. So in order to manage this GitOps workflow, you need an operator in the cluster to do this watch and to pull in its config and configure the cluster. So we use Weaveworks, Weaveflux. It's a tool developed by Weaveworks And it's a Kubernetes native operator written in Go. It sits in your cluster, and it will just watch a Git repository and pull in config, or it will watch an image repository and automatically update Git for you. I'll talk about this a little later in the next slide. But the most important thing here is that weFlux will periodically reassert state. That means it polls Git, checks what's there, and will force a reapply across the top. So if someone's made a config change of some kind, they've gone round your pipeline, and they've just gone into the cluster and changed something, that will get wiped out. This enforces people having to go through your pipeline, having to go through your controls, and ensure that what is running in the cluster is what should be running in the cluster. Unfortunately, Flux won't delete things, but that's kind of a safety thing. You don't want it accidentally, going down, not being able to get to Git, and then just deleting your cluster, because that would be a very bad time. So yeah, sample GitOps workflow. There's two ways of really doing it with Flux. We quite like the top one, which is you do everything in Git, and you don't bother watching the repository. We find this works a lot better with Jenkins and allows us a little later on to pair sort of breaking config changes. So say you've changed the name of a config file. If you do an image repository pull, then you'll be deploying the new image looking in the wrong place, and everything will fail. Whereas if you pair it with the config change in your deployment to put that file in the correct place, this will all hopefully work, provided you've gone through your CI properly, as we know everyone does all the time. So yeah, there's a few little problems we noticed with the GitOps workflow. We feel it's a lot better by default than your standard kube control push out to the cluster. But there are issues. For example, Git access controls are not necessarily the best in the world. They try, but once you're into a repository, you tend to have a lot more access than you may want. For example, you can see all branches in a repository all the time, which is most of the time okay, but if you're configuring your entire cluster state in one repository, this may not be the model you want. There's no external surfacing of completed deployments in Flux using the git push method. It doesn't come back and tell you it's passed. This is a bit of an issue with your pipeline. You've pushed out a deployment, now you want to test it. Well, when do you start testing? Do you just go? You need to know if the deployment has completed. And yeah, as I was saying, registry-based deployments make it hard to pair breaking changes with a new image version. Didn't realize that was animated when I picked it up. Okay, so our pipeline, this is a very sort of pared down Cliff Notes version of what we do, or did. So we built the build your image, you test your image, as everyone, as you do. And then instead of deploying to Kubernetes, we commit our changes to our YAMLs to a dedicated repository for Flux. We then push our commit, and then we watch Flux in the cluster. We make sure it's picked up our commit. That's just a very basic, checking network nativity is the thing actually being found. And then we wait for our deployment to complete as per. And then you run your smoke tests, you run your integration tests, you do your promotion steps. Yeah, it's a very standard kind of pipeline. We just added a few little bits there about pushing to Git rather than deploying straight to Kubernetes. And then once we push to Git, checking that everything in Kubernetes is doing what we expect it to and is actually picking up our deployment. So the other thing we noticed was that you've got the standard way to deploy Flux is one Flux in kube system that deploys everything all the time and is in effect a cluster admin. Now that's very easy to work with, it's very easy to parse, but then you've got what is basically a cluster admin being driven by Git, which, as I said, has some of the not the best access controls. So we devised a solution using multiple Fluxes. So one that sits in kube system, which is cluster admin. This one stays out in one repository all by itself and then cannot be contacted by anyone else. So this means that our cluster admin has a nice little wall around it and people can't just go in, spin up whatever they like, wherever they like. And then the next one is we have a namespace admin, which basically sits by itself and watches a namespace. And it deploys and manages our applications. So the good thing about this is that it means we can heavily limit our RBAC around these fluxes. They can only ever affect one namespace. It also helps with that we don't accidentally get someone cross-pollinating. They push a change to their bit of the Git repo, but they've changed the namespace to be someone else's namespace. With a cluster admin flux, that would immediately get deployed and they're affecting a different project. Whereas with this, they can only ever affect their own namespace and they can only ever deploy what we allow them. So they won't ever be able to push, start making persistent volumes all over the place, mounting host paths, that sort of thing. And since this is a Git-based operation, you can't manage secrets with Flux unless you use something like sealed secrets, which encrypts them, because this needs to be plain text in Git for Flux to pull and deploy. So yeah, as I was saying, with our Git layout, we've got 2 basic repositories per cluster, one for the system, one for the applications, and then we duplicate those for our prod environments and our pre-prod environments. So our pre-prod environments are very agile. You can just push to those very quickly. You can make your changes. And in certain folders, you may not even need to go through the pipeline, say a dev folder. But in our prod ones, we put access controls around these, so Git protected branches. We make sure that who is code owners as well, so that only certain people can merge to certain places in the repository, meaning only certain people can push to certain applications prods. And yeah, basically allows us to set fine-grained access controls, or at least more fine-grained than Git allows us by default. And then the ultimate effect of this is it limits the blast radius of a compromised flux or secret. Since it can only, you should only really be putting your app fluxes in the way of someone who may be coming in to try and attack your infrastructure. They can only ever affect one namespace as opposed to the cluster. Yeah, nice little diagram that I probably should have spent more time on. So the places at the top are our Git repos. Inside Kubernetes, we've got our system flux in the kube system namespace. This is deploying our app fluxes, our namespaces. And then, yeah, all of our RBAC, all of our network policies around those. And then our application fluxes are deploying the app themselves. Has everyone finished taking photos? Cool. So, post-GitOps, that's a very quick rundown of kind of the structure of what we set out to do. Now, in our Jenkins, we've got no deployment secrets for prod. We still have some read secrets for logs, so we can check that Flux is deploying, but no deployment secrets. So if someone gets into our Jenkins, they can't just, base64 encode our kube config, and then just use that to go into our prod infrastructure and do what they like. They can now only go to Git and wait for a PR to be merged, which hopefully people should be checking the PRs they merge. You can hope. Prod gets protected by your standard PR protection of 4 eyes need to be on it to get anything merged. Historical changes are now easier to view because we've got everything based in Git, which means that every single commit depends on the previous commit in order to exist. This means that you cannot go in and change and force pushover without everyone noticing something is seriously wrong, especially if you disable force pushing, as you probably should. Historical changes are now much easier to view from Git. You can just go back a few days, check out that revision, commit over the top, don't force push commit. And then you have your old cluster state should something go wrong, exactly as it was, well, as far as is declaratively defined for Kubernetes anyway. And now Jenkins is compromised. That's still very bad, but our blast radius excludes prod, which is much better than we were with a Jenkins box with all of its little red flags and prod secrets. There are some things we could improve, though. So at the moment, there's manual approvals all over the place. They don't need to be there. It's very easy to chain pipelines in Jenkins, something we just get around to. And we want to entirely remove our Jenkins to Tube API interaction. So this means no longer checking logs. Hopefully, we need to build up our logging and monitoring infrastructure to the point where we can check that rather than going to Kubernetes. So we completely wall off Jenkins from our production infrastructure. And as I said, more complete logging and monitoring. Secrets management could be better, but could always be better. Secrets are difficult, and the story in Kubernetes is not as complete as I'd personally like it to be, but hey. And finally, GPG signing of Git commits. So I religiously sign every commit I make. Not everyone does. And there is an option in Flux to enable GPG signing for the commits Flux may make. So those are a few things that I wanted to move on. And also verification of those signatures. No point signing if you don't check them. Cool. Any questions? Yeah? So at the moment, it's, oh yeah. So he was asking, how do we manage secrets at the moment? So we do use sealed secrets, but we don't put those into the repo with some issues we've been having internally with the way we encode. And it's nothing to do with the actual tools themselves, just our processes. Any other questions? Oh, yeah?
So how do you delete resources?
So that is something that is still a manual admin operation. And there is a good question about whether it should always be a manual admin operation. And I think most of the time it probably should be. You don't want someone accidentally going in, deleting a line of code, and then bye-bye application. Anyone else? Yeah. Oh. Cool. I did not realize that. So it was just saying that the latest version of Flux does actually delete things if you enable the option, which I did not know. Need to go back to it. Cool. Anyone else? Yeah.
We have 9 people watching this stream. And
when you say watching, I'm sorry. Are you waiting for webhooks to come in from GitHub or Git repository or?
Yeah, so what happens when you set up Flux is Flux will, you either give it an SSH or it produces an SSH, and what Flux is doing is it's doing a light checkout and comparing shards initially to see if there is a change in the repo. Then it will pull down the repository and deploy any changes that are necessary.
more questions.
So the question was, how do we deploy Flux on a cluster? And initially, we use Terraform and kubectl to deploy it first. And then once we've deployed our system Flux, that deploys our application Fluxes. No, so Jenkins doesn't deploy our Fluxes. Well, it does. We use Jenkins to kick off Terraform, which deploys Flux. Separate Jenkins, though, in infrastructure Jenkins, not the application. Okay. Anyone else?
Any other question for any other speaker? Last question, last thought. How do you say this? Last thought?
Yeah, final talk.
Come on. No?
Cool.
Well, thank you. Thank you for coming. The next meetup will be someday in June. When? I don't know yet. We will inform you at due course. We went to the pub. I forgot the slides. I knew that we didn't put this. Is it in this Singer Tavern? Just there? Don't follow my directions ever. Anyway, thank you for coming.